Okay, so names within your programs should be informative, concise, where possible, and that requires balance there between information and how long it is. Memorable, so you can easily go back to them. Remember the name, for example, when searching for where it is, and if possible, pronounce it. Okay, and this is an example of a singularly of something that violates all of those principles. So here we have a function whose name is FLLCX, whose meaning is just not clear from that name, and it takes two values and it's called to it. We're passing two values, one a very, very long name, another long name, and parsing them out as to what those names are and what they mean is very unclear. And generally speaking, if we have variables, the broader the scope of it, how broadly it can be accessed, broader it can be accessed, the more care we need to put into its names. So you need to use descriptive names, particularly for globals, sometimes for parameters that are used to alter a function, but shorter names often for local variables. For example, within a type loop, using I in some cases or n is pretty good. Sometimes you may want to say I. So that's I stands for, anyone know what I stands for here? By convention, we use names in software reliably to mean certain things. If I see I, what sort of variable is it? First of all, can anyone tell? What's its type? It's an integer. If you have I as a double, that's like the devil's spawn. Do not override these conventions because they're time honored. People make assumptions based on them, and bugs will be created if you violate them, or at the least you'll waste a lot of people's time. I should be an integer, ladies and gentlemen. And typically it's an integer used as a what? It's an index. Yeah, it's an index. Often it's an index into an array. And what that means is can it take on all integer values? Often, typically, it's going to be 0 or 1. Okay? Reflecting the fact that in an array, the first element is at index 0. So often, for example, it's not always associated with an array, but that's how it's used often. In any case, it's often used to iterate, say, from one number to another. And generally, those numbers are non-negative. There are cases you might use -1 to indicate that the value 1 before the end, or at the end, 1 and -2 for just before that, or what have you. But generally, I tells a lot. The fact that you use I is just not an accident. Don't just use an E or D, something like that. But sometimes you want to give it a name like I city. If you have something that lists cities where your firm has offices, this will be the index of the city in that list. Okay? And it would be some total number of things, number of cities, perhaps. You might call it N city, N cities, or an I city. But generally we have shorter names, and sometimes I and N do this great. However, if you have a global variable in your C code, and it's used from several modules, calling it I or calling it N is just not going to be helpful. You want to give it a clear name for what it does. Okay? You want to give it a name that communicates its role, sometimes communicates how it's used, or what sort of information it holds. Okay. So these naming conventions reduce risk of errors, ease understanding of code, lower risk of named clashes, and ease search. So time was when I was doing commercial software development, where knowing how a certain quantity is used in a program, or what a certain method did, what a certain function did in my program, I could derive about 80% of the time I know what I named it. And I could search it and find where it's used. Without going and looking it up directly, I would know what it should be named. These things are really convenient. They can save a lot of time. So let's talk about some naming and some fragments of code. Okay, so here's a bit of code. First of all, what language is this? C or possibly C++, possibly fragment C++, but in many cases it's C or C++. So here we have a definition of to what up top. Sorry? Okay, those are two constants. So they're actually here we're saying the value true, all in caps, can be substituted by the value 0. It's really just equivalent to the value 0. It stands for the value 0. False stands for the value 1. So the fact that these are in capital letters implies immediately to a C programmer that they are what? Constants. You know just by looking at it, this is a constant. That's really helpful. If you see code that goes scattered in there, you know it's constant. For example, if you saw this code, even without that, you'd know, oh, I'm dealing with a constant. Now, how about this lower first of all, what does this code do? Okay, so in a very conceptual sense, it's seeing something else. What is getchar here doing? It's taking inputs, say from standard input from a file, and it's seeing if it's at the end of the file. Yeah, that's what EOF stands for. That, ladies and gentlemen, is also a constant. I know that just by looking at it, because it's all capitalized. Getchar is a what? It's a function. By convention in some C programs. And again, conventions differ for different areas of C space, but a function would be all uppercase like that. Now we have this thing, not EOF. How clear is that? Yeah, it's a double negative, which is known psychologically to really throw people off. We might think it's obvious, but it's not. It throws people off, particularly, ladies and gentlemen, if you're working 11 o'clock at night and you've got to deliver code for your client tomorrow morning at 8 o'clock. You don't want to be dealing with not EOF and having not of EOF or what have you. So this can improve it a little bit. So here we're saying, okay, is EOF in a certain stream, standard input stream, that stream accepted, for example, by sort here. Is that equal to in the file? Okay. If so, then that's true. This code could be done in another way. I'm not saying it's terribly privileged, but here we have a somewhat improvement in things. But big picture here, you're already seeing certain conventions coming through. Time-honored conventions. And if you violate them, you do so at your own peril. If you were to not capitalize these constants, put them all in lowercase, it's going to throw people off. They're going to be confused as to what sort of things they are if you put them in camel case in other cases. Okay, here's another function. So I'd like you to make some suggestions on how this could be improved. First of all, what does this code do? What does it mean? It's a function in C. What's it mean? Okay, what does it actually do? Okay, it compares two strings, and what's the result? So it takes as arguments, it takes as parameters for it, what? What does it take in? It takes two strings, and what does it produce as a result? This is probably useless. And what does it return? Okay, it does return integers, and what integers? Often, ladies and gentlemen, we want to be able to summarize what a function does, abstract away from how it does it at first. So it takes two strings, and could anyone summarize what the job of this function is? Okay,
For some reason returns the reverse.
okay. So in other words, it returns 1 if the first string is lexicographically less than the second string. Yeah. So in other words, if you gave it, 2 strings, A and, Z, spelled out, it would return what? 1. It would return 1. So that is less than 0, so it would return 1 and 0 otherwise. So it performs some job, but in order to figure that out, ladies and gentlemen, was that obvious from its name? If you saw a call to this in a program, and this is often where the complexity comes in. Suppose you saw some code that was using this function. Use it here, use it there, and Averton was calling concat. Do you understand what concat does? Just by looking at that? Okay, you can go look at this code. Software engineer, you can go look at the code. You look at the code, you waste a couple minutes trying to figure out what it does. A much better solution, folks. You don't want everyone who uses your code to have to read your code in all its details unless they absolutely have to. You want to use names that are clear. So, so maybe you have something like this. I'm not saying this name is particularly privileged, but it's better than concat. Is first smaller? Is first string smaller? See, it clearly takes 2 strings. This one an S and T, so you have string 1, string 2. And this name communicates that it's returning something that's true or false, because it uses the term is, which by convention indicates a Boolean. It's returning true or false. And this tells us something about what it does. It doesn't give all the information. It'd be nice to have some comments here that explicate this further. But if you saw calls to this, you'd have some clue as to what it's doing. In contrast to concat, where you can come to very, very misleading notions of what it does. Here, is this first one smaller than that? You could say it's first lexicographically smaller. Firstly, I would be more inclined to that because I think it's clear. It's not treated as a number, and it seems a bit smaller. It's lexicographically smaller. But the point here is we have their name. You notice another thing which is going on. First of all, we replace this 1 by true. Secondly, this 0 by false. In other words, we're clearly indicated we're returning a Boolean value. If this code were longer, you wouldn't have to worry that it's returning 2 somewhere else or whatever. It makes clear that it's returning a Boolean one. So, ladies and gentlemen, a lot of the trick here is to try to minimize the chance that someone will have to look at your code in the first place. So giving it a good name for a method, for a function, helps a great deal. And if they need to figure out how it works, great, but if you can give it a nice name, particularly if you could have a couple comments on here that back that name up with additional information, it means that they don't have to wade through the reasoning, they don't have to look up how Stewart works and figure out how your code works by extension. Okay? So that's a further example. So let me just